guys, in this video I'm going to show you how to solve linear equations. I'm going to start this first video pretty basic, and then I'll have some additional videos about the same topic that will expose you to just maybe some more complex equations. But take a look at these equations. We know it's an equation because of the equal sign, okay? If there was no equal sign at all, if it was just the expression x over 8, there's not much we could do with it. But now that we know x over 8 equals something, it equals 4, well, now we can actually figure out what the missing value is. So it's kind of like, you know, a mystery puzzle. We're looking to see what could the missing variable be. So the key to solve these problems is that we want to isolate. So this word isolate is to get alone. We want to isolate the variable, okay? Because once we have it boiled down just to the variable, it will equal a value and we'll be down to our final answer. And so the best way to start attacking these equations is to use the orders of operation but go backwards. So instead of doing the multiplication and division first, you know, after the parentheses and exponents, and then adding, subtracting, we're going to start by adding or subtracting a value and then multiplying and dividing a value. So as we work through the problems, I'll let you know what I mean. Take a look at this first one. X divided by 8 equals 4. Okay, so right now our missing number is being divided by 8, and when it's divided by 8, the value is 4. Okay, so to undo this problem, to work it backwards, instead of dividing by 8, we're going to hit the rewind button and multiply by 8. We're going to see what it was like before it got divided. So wherever you want to kind of write, you know, I just kind of put a little dot for multiplication. So 8 times 8. And this is actually not 8 times 8. I guess I could, it's really multiplying it to the whole fraction. So that simplifies to 1. Over here, well, 4 times 8 is 32. And because this 8 in the numerator simplifies with the 8 in the denominator, we are just left with the value of x. Now this one's a pretty simple one to check. We're saying, okay, x is 32. If we check our answer, 32 divided by 8, well, sure enough, is 4. Okay? All right, so let's move on. This one, as you can see, it's a little bit longer, has a couple extra number involved. And so this is where I really want you to pay attention that we're going to do orders of operation backwards. We are going to start with any number that's being added or subtracted. We're going to take that number away first, and then we're going to move to multiplying and dividing. Okay, so if you look at this problem, -6 plus x over 4 equals 5. This number right here, okay, is what we're going to move over first. So right now, the value -6, we want it to disappear. We want it to go away. That number to go away is, we want this whole value to equal 0. To do that, we're going to put the opposite operation and the same number 6, because -6 plus 6 is 0. So this, you can actually just kind of cross this out because we're done over here. But because it's an equal sign, you have to treat everything fair. Over here you need to add 6. Okay, now we have x divided by 4 equals 11. Okay, now similar to this first problem, we have x divided by 4 equals 11. We are going to multiply by 4. Okay, again, the 4's over here simplify to 1. In this problem, we get x equals 44. Okay, let's take a look at 2 more. Number 3 says negative 15 equals negative 4m plus 5. So we've been talking about getting this variable by itself, and doing so by working the orders of operation backwards. I always want you to start, I want your eyes to start wherever you see the variable. Okay, this time it's on the right side, which may look a little different for you, but we can still work this problem out even though it's on this other side. Okay, so focusing just right here, this is the part where we're going to start doing the orders of operation backwards. So we're going to look to see if a number needs to be added or subtracted first. Okay, right here, this was a plus 5, and if we want that plus 5 to go away, to disappear, we're going to subtract 5, because 5 minus 5 is 0. You can actually cross this completely out. Because it's an equal equation, we're going to have to do the same thing over here. Now I want you to be careful with these negative numbers. So this is negative 15 minus 5. So it means we're going lower. So it's a negative 20 equals negative 4m. Got to be careful, I'm going to run into this other problem. The last thing we're going to do, we're going to still focus on the side that has the variable. Don't get distracted by the negative 20. Go back over here. Okay. Negative 4 is being multiplied, and so the opposite of multiplying, remember we're going to rewind it, is to divide. So negative 4 over negative 4, that simplifies to 1 whole. That's why we can cross this out. And then negative 20, write it really small, negative 20 divided by negative 4. So this is 2 negatives being divided, which is a positive. So for this problem, m is going to equal 5. And of course, you can take the time to go back to your original problem, plug in 5, and resolve it, making sure you got it right. Okay, let's take a look at this last problem. We have n plus 5 all over negative 16 equals negative 1. Okay, I purposely chose this problem because I've been saying for the past 3 problems, work the orders of operation backwards. So starting with add, subtract, and then multiply or divide. Well, there's an exception to that rule, okay? Because of the way this problem is set up, and specifically because our variable is located in the numerator, okay, we can't really even get near the numerator until the denominator is gone, okay? And so this is the exception to the rule. So we're going to have to first start right here with this divide by negative 16, and we are going to multiply this entire fraction by negative 16. Now we don't even have to do that math. We can just say the multiplication by negative 16 and the divide by negative 16 cancels each other out. It simplifies to 1 whole. But don't forget to multiply over here. So on the right side, negative 1 times negative 16 is a positive 16. Okay. Now that we have the denominators out of the way, our numerator can just come on down. So now we have n plus 5 equals 16. Now we can work on our add, subtract. This plus 5, the complete opposite, if we were to rewind the problem, we're going to subtract. That cancels to 0. And n equals 16 minus 5, which is 11. And again, take some time and go back and plug in 11 because you want to make sure you get the problem right. Okay, I want you to pause the video. I want you to try some of these problems on your own.